So can you all see my screen? All of you, please.
Yes, sir.
Yeah.
Yes, sir.
So we are going to learn statistics in an interesting manner with the help of the, some sports analytics. So how's the analytics, sports analytics and DMAX goes hand in hand. Probably all Wednesday I will be meeting you in this manner. And towards the end, I will also explain you a case study where the Six Sigma methodology, Six Sigma approach, and the Six Sigma tools, particularly statistics, how it is used in sports, particularly for their process improvement or result improvement. All right. So my Wednesday classes, the idea is this. Understanding descriptive versus inferential statistics. So what is statistics? What is descriptive? What is inferential? And then data worthiness. We have data. Whether this data is worthy for analysis or are there any error involved, any uncertainty involved. If the uncertainty is more, which means you can't rely on whatever information your data is conveying. Your data is conveying something, but its reliability is poor simply because the uncertainty is more. What is uncertainty? That is the error. And then a case study, right? So this is how I will be progressing. This has nothing to do with our main session, but sitting in this class will definitely leverage your understanding in the main session. All right. So the first point, descriptive statistics. So what is descriptive or description? You are just describing describing something you observe. Whatever you observe, if you are, let's say you are narrating for about a page, and that is called generally description. Similarly, in statistics, if you describe something using numbers, that is actually called descriptive statistics. Let us say you are doing a survey. You're doing a survey like in a specific area, signal point, there is heavy traffic. And you have been doing a survey. You are there for about 30 days. And every single day you are noting down what is happening, particularly in the peak hours. What is happening, you are noting down. How many buses are going and how many two-wheelers are going, how many public vehicles are going, and everything you are noting down. And now finally, after your study, you are able to describe something. You are able to conclude something. And this is your statement. On an average, 3,000 vehicles crossed the signal point, particularly during peak hours. Out of the 3,000 vehicle, passenger cars are about 3,350, public vehicles are about 600, and two and three-wheeler parts the remain, contributes to the remaining 1,050. And now, do you understand? You have described whatever you have observed in the form of some number, some statistics. This is called descriptive statistics. Whatever you observed, you have now expressed in the form of a number so that the other person can properly understand about your observation. This is simply called descriptive statistics. So all of you understand what is descriptive statistics here?
Yes, sir. Yes, sir.
Yes, sir.
Very good. So now, you have collected data, you have collected the data, and then you have presented the data in this form. This is your data collection sheet. See here, date-wise, number of vehicles, and again, the split up of the vehicles, and everything you have presented. And then, in fact, you have also visualized it, and then you have also summarized it with some numbers. Overall, there are 3,000 vehicles that are crossing during the peak hours. 45% of them are passenger cars and 20 of them are public vehicle, and remaining are your two and three wheelers. So statistics is the science of So statistics is the science of collecting. We have collected the data. Am I correct? We have
Yes.
collected the data. Organizing, we have organized it date-wise, table or column we created, right? Organized. And then we presented it, maybe, in a visually appealing manner, some pie chart, some bar chart. And then we analyzed what is that the data is telling. We calculated the percentage. And then finally, we interpreted the data to assist in more effective decision. So what is exactly happening in that particular signal point? You are now able to understand after completing your study over a period. Now you can make the recommendation. What needs to be done? Whether can you make some changes in the what do you call the route, or do you want to go for a flyover, right? And some important decisions you will be able to make it, which is actually called statistics. Which is actually called statistics. A collection of numerical information can be called as statistics, right? And see here, these are all numerical informations. Can you see every statement is having a number, right? So a typical automobile in US travels 11,000 miles per year. So how do they know? They actually collected data, right, over a period of year. So they realized that on an average, every automobile in US in a year, it covers about 11,000 miles. A typical bus, 9,350 miles. A typical truck, 13,900 miles. So these are all based on their way of documenting the events in the form of data, and then they are able to come out with meaningful summary, right? In Canada, the corresponding information is 10,300 miles for automobiles, 19,800 miles for buses, 7,000 miles for trucks. And the mean waiting time for technical support in your company is 17 minutes. This is the statistics. On an average, everybody coming to your company for technical support, they have to wait for at least 17 minutes, right? So hope all of you understand what is statistics. We will again divide the statistics into two parts. What is that called? One is descriptive, another one is inferential.
Inference.
So we will come to that a little later. And before that, the basic statistics. Why statistics? There are three purposes. Statistics generally serves three purposes. First purpose, it helps you to summarize the data with the central value. You remember in all our statement, whatever number we have seen, this is a central value. Am I correct? I have used the word average, isn't it? On an average, what do you call?
Yes, sir.
The
Central tendency.
Yes, exactly. The central tendency is used. So we want to summarize the data with the central value, and you can also use the data to assess the degree of variation. To assess the degree of variation, and degree of variation can be measured in terms of range, in terms of standard deviation, in terms of variance. Mostly standard deviation is used because it is advantageous than the other two. Similarly, mostly mean is used because in most of the situation, mean is helping us to understand what is actually happening. And the third one, you can also explore possible difference between the group. In US, how many vehicles are, how the vehicles are moving. In Canada, how the vehicles are moving. And you can actually figure out the difference. You can actually figure out the difference. Now tell me, in my statement between Canada and US, where the movement is high, is that the movement is high in particularly, let me say for the buses, where the movement is high? Is the movement is high in Canada or in US? Movement per vehicle.
Canada.
Yeah, in Canada. So you can also figure out the possible difference that may exist between your groups. So all of you understand the three important uses of statistics. One is you summarize with central tendency. The other one is you assess the degree of variation. If the degree of variation is high, then your summary may not be realistic. Do you all of you agree with my statement? If the degree of variation is too high, then your summary, the summary statement you made with the central value may have a lot of uncertainty. But when the variation is too low, then whatever statement you are making, that will be more and more realistic and will have, more meaning in real time, right? And third one, you can also compare two groups with the help of the statistics. So now there are a set of number here. Hope all of you can see, right? How many numbers are here?
12.
Yes. How many numbers are here?
12.
12.
12 numbers are here. That itself is a statistics. Can you see n equal to 12?
Mm.
That itself
Yes,
is
sir.
a statistics, right?
Yes, sir. Yes, sir.
And then there is mean. Tell me what is mean? Mean is average, right? How will you calculate mean? Can one of you explain? One of you please
First we
explain.
need to add all the values and then we need to divide the total number.
Very good. We need to add all the values. Since there are 12 numbers, we divide the sum by 12. That is your mean. And there is standard error of mean. I'll talk about standard error of mean slightly later on, but standard error of mean helps in locating your confidence limit. What is the purpose of standard error of mean? Standard error of mean helps in locating your confidence limits. For that, first of all, we should know what is a confidence limit. Then we will see how the standard error of mean can help in locating the confidence limit. And then trimmed mean. TR mean means trimmed mean. Trimmed mean means mean is how much? 3.833. All of you know trimming? Trimming means we cut down a small portion, isn't it?
Yes.
So the 3.8 is trimmed to 3.5. That's the meaning. And then standard deviation. Hope all of you learned on day 2 how to calculate standard deviation. Please confirm if you know the formula. All of you know the formula, right?
Yes, sir.
What is the formula? Square root of
Summation of x minus x bar divided by n. I think after that we have to put root.
Yes.
Divided by n minus 1.
Yes, in case of sample mean.
Square root of summation of x minus x bar, the whole square, first of all, divided by n minus
1.
1. So this is the formula for standard deviation. We can use two symbols. One is sigma, another one is S. Sigma is for
Sample mean.
population.
Oh, population.
S is for sample, right? And for sample only we have n minus 1. For population we will have n. That is the difference. All right. So the standard deviation is calculated and variance is nothing but square of the standard deviation. Hope all of you are clear with that, isn't it? The variance is nothing but square of the standard deviation. Yeah. And then variance is square of the standard deviation. Sum means total of all the 10 numbers. You add all the 10 numbers, you get the sum. Minimum. And looking at the number, tell me which is the minimum value. Which is the minimum value here? 1 is the minimum value. So which is the maximum value here?
10.
Very good. You can see minimum 1 and then maximum written as 10. The difference between the minimum and maximum is called the range. Can you notice here? Range equal to 9. 10 minus 1 is 9. All right. Done. Now, there is something called mode. Mode means the most frequently occurred number. Look at this. Look at the series here and tell me which number is frequently occurring.
3.
So 3 is the mode. 3 is the mode, right? And how many times it occurred? 4 times. N for
4 times.
4. And now there is something called quartile 1. This is called quartile 1. If you look at the number, tell me, is this number arranged in increasing or decreasing order?
No.
No. So in order to figure out quartile 1, you must arrange the number in increasing order. Then find out the point below which 25% of the data should be available. Then and so above which 75% of the data will be available. Say for example, just approximately I'm doing, right? Let me say I just draw a line, and below the line, 25% of the data is there. Above the line, 75% of the data is there. Then this line is called quartile 1. All of you understand the definition of quartile 1?
Yes, sir.
Suppose if I draw a line exactly, let's say in the center, and now to the right side of the line, 50% of the data is available, and left side of the line, 50% of the data is available. And now the line is called quartile 2. Quartile 2 is also known as median. All of you understand what is median? Exactly to the right, 50%. Similarly left, 50%. Then it is called quartile 2, otherwise called median. Similarly, I draw a line here. 25% of the data appears on the right side, and 75% of the data appears on the left side. Now the point is called quartile number 3. And in order to locate the quartiles, you have certain formulas which I will explain in the next slide. So other than the quartiles, everything else is clear to each one of you?
Yes, sir.
What is interquartile range? Q3 minus Q1.
Difference between highest and lowest quartile.
Difference between Q3 and Q1. Q3 minus Q1 is called, the interquartile range. What is the other name of quartile 2?
Median.
Median. Very good. Fantastic. Median is also a central tendency. So now we move on. Let me erase all these things. Oh, here also something is there, right? All right. I want some of you to be on video. Why you are leaving me alone in the class? Few of you, or even better, all of you, I have already told you, feel comfortable, right? And this is not, don't consider this as a class. This is a meeting between you and me, right?
Traveling a 4-minute train, sir.
Yeah, you are an exception, right?
Actually, I am facing some issue with the video. I am
Again, you
even trying to
Right.
on, but it just flashes. And
Statistically, situation is very bad, right?
It off.
Everybody is
I
facing
don't know.
issue. All right. So now, descriptive statistics, right? Now, whatever I have observed, I have described. Imagine you have seen your girlfriend and someone is asking, how is your girlfriend? Then you are writing one page about your girlfriend. You are describing how beautiful your girlfriend is. Same way, whatever you have observed, if you could describe in the form of number, that's called the descriptive statistics. That's called the descriptive statistics. And now, whatever you have observed here, like the heavy traffic, and now you are planning for constructing, let's say, a flyover. If I construct a flyover, maybe after 6 months or so, how it is going to be beneficial to the public? Now you conducted the study by the present situation. The past situation also you studied, till present also you studied. But now you wanted to talk about the future. If a flyover is constructed, how it is going to be beneficial to the people, public? How many people might get benefited, right? And now the answer is called inferential statistics. Based on whatever you have observed here, will you be able to answer this question? If a flyover is constructed, how it is going to be beneficial to the public? Will you be able to predict something? Yes or no? Come on, guys. Is it possible based on whatever you have observed, and you are giving a proposal, let's say to the government, right, to construct a flyover? Now government is asking, okay, you are suggesting to construct a flyover. We have to invest several crores. How it is going to be beneficial? Will you be able to supplement your proposal with some benefit statements? Yes or no?
Yes, sir. We can use some data.
Then your data is, then your statistics now is called inferential statistics. So studying about the present and the past is called descriptive. Predicting the future is called inferential. Right? Hope it is no Clear. Similarly, if you describe your girlfriend, then that is descriptive. Based on the girlfriend, you are predicting, let's say, how her mom will be. Now it is inferential, right? So based on what is observed, you are predicting something else. Similarly, you can always, compare between sample and population. You can always compare between sample and population. Based on the sample, you can judge the population. Whenever it comes to a judgment, it is inferential. Whenever you are simply describing what you observed, that is descriptive. Otherwise, the known characteristics, if you write down, it is descriptive. If you are estimating an unknown characteristics, it is inferential. How many of you understand the difference between descriptive and inferential? All of you?
Yes,
Let us say I have a bucket full of balls. I have a bucket full of balls. 100 balls are red color. 100 balls are red color and 90 balls are yellow color. 80 balls are blue color. And total number of balls, how many?
270.
270. And now this is a statistics. A bucket full of balls. 100 of them are red. 90 of them are yellow. 80 of them are blue. And total is 270. What is this statistics?
Descriptive.
Descriptive. Descriptive, right? You have a bucket full of balls and you described it, how it is distributed. Now it is descriptive. Now I randomly pick 3 balls. 2 of the balls are red color. What is your judgment about the balls in the bucket? Which color is dominating in the bucket? I randomly picked 3 balls. 2 of them are red. So what kind of statement you can make now? The red color balls are more in the bucket. Can I say like that?
yes, sir. Yes, yes.
Since red color buckets are more, you are able to get two of them as red. Now, what is this called? Inferential. Now you do not know what is inside the bucket, but you randomly picked some balls and then you saw red, dominating. And so you are saying that in the bucket also red will be more. You have not counted the balls now. Now the statistics is inferential. Do you all understand difference between descriptive and inferential? In your business, most of the time you are playing between the two. You are doing either you will be, whenever you have data, it will be either descriptive or inferential. Is it clear with everyone?
Yes.
Sir, can I get one more example on this inferential statistics?
One more example.
Yes.
Okay. So let's say, you wanted to admit your child in a school. You want to admit your child in a school. So what do?
I will take the review of the school.
Yeah. In the school, there will be several thousand students studying. Will you be able to take the interview of all 1,000 students?
No, cannot.
5 or 10 people. And all of them are telling, the school is excellent. What will you do? You will take a decision to admit your child.
Yes, sir.
Now, what is this you have done? You have studied a sample of 5 people and,
Yes,
decided that everyone will have the same opinion. Am I right?
Yes, sir.
What is this? Descriptive or inferential?
This is inferential. This is
Inferential. You studied a sample and judged on the population. Similarly, your quality inspectors in your company, are they doing 100% inspection?
no, sir.
Then what are they
No.
doing? They are doing inferential statistics.
They are taking
They are
sample
only taking
and
sample, and based on the sample, they are delivering entire population to various clients.
yes,
Am I
sir.
correct or not? Since the sample is good, they simply believe that population will also be good. There is a risk involved. Don't worry. There is a risk involved. That is what called as uncertainty. That is what is called as sampling risk. Life always comes with risk, isn't it?
Yes, sir.
Right? So sampling also always comes with risk, with what we call it as sampling risk. Right?
Yes.
The percentage of permissible sampling risk is called level of significance. It's called level of significance. We'll slowly understand that. So whatever I have written here, I think it is now easy to understand, right? Study conducted over a period and you have You have written down the known characteristics of whatever you observed, which is descriptive. And then benefits. Benefit means what is going to happen. We really do not know at this point of time, but still we make an estimate, which is called inferential. Can one of you read out the statement? One of you read out the statement.
As in previous example, 3,000 vehicles have crossed the signal point during peak hours. 45% of them are passenger cars, 20% are public vehicles, 35% are 2 and 3 vehicles.
So what is this statistics?
Descriptive.
Descriptive.
Very clear, right? Very obvious, right? So descriptive statistics are the methods of organizing, summarizing, and presenting data in an informative way. If you use data to summarize the characteristics of a population, your approach is called descriptive statistics. An average person spends $103 on a traditional Valentine's Day, right? In 2020, 2 years before it happened, and data is available, right? Now you have summarized, right? That means it is descriptive. Similarly, inferential. If you use data to estimate future population, your approach is called inferential statistics. Our main concern regarding inferential statistics is finding something about a population using a sample taken from the population. We want to find out the characteristics of the population only by studying few samples. What is important? Samples should have been taken from the population. You want to admit your child in school A, then your survey should be with the students who are studying in school A. By mistake, if you take a sample outside of the population, sampling is of no use, isn't it? The error will be too much. So inferential statistics are the methods used to estimate a property of a population based on sample. Using a sample to learn something about the population is done extensively in business, agriculture, sports, politics, and government. Happening or not? Even before the polling, people judge about which party is going to come to the ruling. We all do that. That means those are all inferential, right? But once the polling is done and summary is created, that is descriptive. All right. So you are very clear with the descriptive and inferential statistics. Hope the point is very clear. Now, moving on. See here, Virat Kohli. You all know Virat Kohli, right? The famous Indian cricketer, right? He was also the captain of Indian team, right? So Virat Kohli, his batting average is 59.62. Last 1 year performance or 2 year performance, his batting average is close to 60. And now he is going to play. He is going to play a match, let's say tomorrow. How much he is expected to score? If somebody is asking you a question, how much he is expected to, what do you think Virat Kohli must score tomorrow? And what will you say? Suppose if I ask you the same question. Kohli's average is, batting average, 1 day match is, having 59. And tomorrow is a match. And what can you expect from Kohli? And if I ask you the question, what will be your answer? Come on, make it right.
He may score around 59. Somewhere around 59, like 50
Exactly.
or 60.
That means average is nothing but the expected value. Average means expected value. Whatever is the average, that is most likely to happen. Whatever is the average, that is most likely to, if you are above average, that is most likely you are a common fellow. If you are far above average, then you are extraordinary, right? So you might say he will score around 59.6. That means approximately between 50 and 70. Between 50 and 70, which means your confidence limits are 50 and 70. The lowest you can expect from Kohli is 50. And the highest you can expect is 70. To certain percentage, you are confident that, Kohli will score between 50 and 70. Now you are more safe, isn't it? Your statement, you are making in a more safer manner. Suppose if we ask you how much is going to be your black belt score, examination score, will you tell me a single score? You can't, isn't it?
No range.
You will also give the range because you want to be safer with your statement. So the more wider, the more confident you are. Am I right? The more wider, the more confident you are. So in order to increase our confidence level, we keep a range. But the challenge in statistics, challenge in business is you should achieve highest confidence level, at least 95% confidence level. At the same time, the range should be minimum. Then only people will appreciate your decision. This is called the art of decision making. This is called art of decision making statistically. So now between 50 and 70, 50 is called lower confidence limit. 70 is called upper confidence limit. This is lower confidence limit. This is upper confidence limit. If you see what I explained, he played 1 year match and now next day's match you are predicting. Next day's match you are predicting. Then it is called, then the limits are called prediction interval. Instead of calling it as confidence interval, confidence limits, you call them as prediction limit. You understand? You are predicting the score Virat Kohli is going to get in the next match, one single match. So what is that called? Prediction limit. Suppose next 1 week, Virat Kohli will be playing 5 matches. Virat Kohli will be playing 5 matches. Already what you have? Average. Now I am asking you a question slightly differently. What could be the batting average of Virat Kohli in the upcoming series? Now how many matches Virat Kohli is going to play in the series? 5 matches.
5.
Now what could be his average, batting average in the particular series? Average of the 5 matches, isn't it? Now your limits are called confidence limits. You understand the difference between prediction limit and confidence limit? Confidence limit means that is also a prediction, but prediction of the average. Prediction of the average is called confidence limit, but prediction of a single observation is called prediction limit.
Prediction.
Clear? For prediction limit, we will be using standard deviation. For locating prediction limit, we will be using standard deviation. For location of confidence limit, we will be using standard error of mean. For predicting the prediction limit, we will be using standard deviation and the mean value. See here, 59.62 plus or minus 1.96 standard deviation. When I use standard deviation, it is prediction limit. Instead of standard deviation, if I use something I have shown already.
Standard error of mean.
I wanted to show you again. Standard error of mean. So what is standard error of mean? Now is the time. Standard deviation divided by square root of n. Standard deviation divided by square root of n. Here what is n? N is the number of samples you have taken. Standard deviation divided by square root of n is called standard error of mean. When I use standard error of mean, the limits will be called, can one of you answer this question? Confidence limit.
Confidence.
Very good. When I simply use the standard deviation, the limits will be called prediction limit.
Prediction.
Very good. All right, we go. Don't worry, repeatedly when you use, you will become very familiar, right? So whatever you could grab from me, that's good right now. Now, the accuracy of finding the inference. Accuracy of the inference you draw depends on the variation in the data. Am I right? See here, What is this? This is confidence limit. Sorry, this is prediction limit. Average plus 1.96 into standard deviation. Why 1.96? How many of you know normal distribution? Plus 2 standard deviation on the right side, plus 2 standard deviation on the left side. What will be the area inside the curve within 2 standard deviation from the center? Let me draw the normal distribution. I draw the normal distribution curve. See here, I draw the normal distribution curve. This is the average. This is 2 standard deviation from the average. This is also 2 standard deviation from the average. Now what will be this area? Hatched area. 2 standard deviation. What will be the area? Have you studied this on day 2? Shivashis could have taught you. What is the percentage? What is the percentage?
95.45.
95.45% of your data will always lie within 2 standard deviation from the mean value. 2 standard deviation from the mean value. Mean is at the center. Mean plus 2 sigma. Okay, mean plus 2 sigma, and this is mean minus 2 sigma. This, if you take this range, you are sure that 95% of the data will lie. 95.45. In order to round it to 95, I am reducing the 2 to 1.96. Right? Slightly I have to go inside. Now the area inside my line will be 95%, right? All right. And suppose if I go up to 3 sigma, my center is mean, I move away from the mean up to 3 sigma. Now what is this line called? Upper control
Limit.
3 sigma on the left side. What is this line called?
Lower control.
Imagine when I go up to control limit, beyond the control limit, there is not much available. The curve has already started, going closer to x-axis. Can you notice that? That means when you go up to 3 sigma limit, what percentage of the points are now covered?
99.73, I think so.
Very good. You are absolutely correct. That means when you take 2 standard deviation, your confidence level is approximately 95%.
90.
When you go up to exactly 1.96, you are exactly 95% confident. When you go up to 3 sigma, your confidence is 99.73%. Right? Once you know average, once you know standard deviation, you are now able to locate the limits. And for prediction limits, use sigma, which is standard deviation. And for confidence limit, use sigma by square root of n. This is called standard deviation. This is called as
Standard error of mean.
Standard error of mean, right? Plus or minus 1.96 times standard error of the mean means what are you getting? Confidence limits. Plus or minus 1.96 times standard deviation means you are getting prediction limit. Clear? Right. So I gave some idea about the confidence limit and the prediction limit, as well as when to use standard deviation and when to use the standard error of the mean. Right. So accuracy of inference depends on the variation in the data. If the variation is too high, then your accuracy of information, will be very low. If the variation is less, then what will happen? Your confidence limits will be close to each other. So of course, the standard deviation affects your confidence interval. So lower the error, narrower will be the confidence interval. Can I say this statement? Lower the error or lower the variation, narrower will be the confidence interval. Right? Narrower the confidence interval, conclusions will be more accurate and meaningful people will start appreciating, your conclusions. Now, imagine the first batsman is, Virat Kohli. What was our conclusion? Virat Kohli's average is 59, am I right? And now let us say our confidence limit for Virat Kohli is 55 and 65. 55 and 65. Now the second batsman is Rohit Sharma. So this is Virat Kohli, first one understood. And his confidence limits also indicated. Now next batsman Rohit Sharma. 57.87 is the average. Here is the average. Lower confidence limit is 57, upper confidence limit is 63. And the third batsman, Ajay Jadeja. Average is 31. Lower confidence limit 25, upper confidence limit 40. And now there are three batsmen. Now you have to choose two batsmen for your team. Tell me whom you will choose.
Obviously, Virat Kohli and Rohit Sharma.
Why? Why you excluded Jadeja? Wow.
Because average.
Average?
On the basis of average.
On the basis of the average. See, you want to clearly exclude Ajay Jadeja in the team. Simply because you are very confident that Rahul, Virat Kohli and Rohit can significantly play better than Ajay Jadeja. That is why you opted these two. Am I correct or not?
Descriptive data itself.
Right? You have gained the confidence because the confidence limits have not, interfered here. The confidence limits have not overlapped here. This is 40, this is 57. There is a clear gap. Can you see a clear gap here? This is called significance. Now the difference is significantly different. That is why you boldly told, sir, I will choose only these two. I will not consider Ajay Jadeja. But now I go for another question. You have to choose only one person. Now tell me whom you will choose.
I will go with Kohli.
You will go with?
Virat Kohli.
Kohli. But do you think Kohli will definitely play better than Rohit in the next series?
Next series maybe.
Earlier, no, there were no confusion. Yes, definitely, no, these people will play better than Jadeja. But now there is a confusion. That means the difference what you are seeing is not significant enough for you to make a conclusion. Am I correct? The difference what you are seeing is not significant enough. You are not able to gain enough confidence. Right? Generally, we wanted to make decision with the 95% confidence, which is also the industry standard. That is why the 95% confidence limits are indicated here. Can you notice the confidence limits? The confidence interval or confidence interval for Virat is here, and this is Rohit is here. Can you see a major portion overlapping? Am I right or not? So starting from this point till this point, there is an overlapping. This overlapping is called the error in your decision. This overlapping is called the error in your decision. More the error, lesser will be the confidence. Lesser the error, higher will be the confidence. Clear to all of you? So, for taking a decision, who is better, your confidence level is very low. Very, very low. That is the reason why better, we should keep quiet under such a situation. Instead of making conclusion, better avoid making conclusion whenever the difference is not significant. Do you all understand what I'm saying now? Now you see between Jadeja and Rohit, yes, you take a decision. Between Jadeja and Kohli, you take a decision. But when it is the comparison between Rohit and Virat, it is better to keep quiet. Don't take decision. Because you do not have enough confidence. You do not have enough confidence. All right. So Virat performance is definitely better than Jadeja. Statistically significant. Rohit's performance is better than Jadeja Yes, all of us will agree. Yes, statistically significant. But when I say Virat's performance is better than Rohit, this statement doesn't have 95% confidence. Please understand. This statement doesn't have 95% confidence. When you say 95% confidence, the confidence limit should not overlap. See here, the confidence limit 40 is here, and for Jadeja, this side is 40, and for Rohit, this is 57. There is no overlapping, isn't it? How much is the difference between the two? 40 and 57. You have 17 units difference. But when it comes here, 57 is the limit this side, 63 is the limit this side. And here, no, 55, up to 55, there is overlapping. Can you notice that? Up to 55, there is overlapping. Only, no, the small 2 is without any overlapping. Similarly, this side, up to 63, the situation is same. So, no overlapping situation is very, very small. Overlapping situation is very high. When you compare between Jadeja and Rohit, there is no overlapping at all, right? 25, 40, the entire range is outside of this range, isn't it? So that's the reason why we say statistical significance. All right. So this is the case. This is we have discussed already. All right. So any question to me based on whatever we discussed so far? Any questions? Questions?
Yeah, yes, sir. If there is a very less significant difference, and still if we want to choose someone or we need to take a decision, in that case, how we can take the decision, or we can choose someone?
Yes. See, first of all, when you want to take a decision, you must declare your confidence level in the decision. You must declare your confidence level in the decision, right? So let me show you my, let's say, whiteboard.
Nageshwaran, can you please mute yourself? It is the background noise is very high.
Right. Okay. See here. Now I have shared my whiteboard, right? And now this is my confidence limits. Maybe any confidence limit. Right now, let us keep it 95% only. So 95% confidence limit. Let us assign some value, 40 and then 60, which is nothing but my test mark. My test mark. I'm expecting that my test mark is going to be between 40 and 60. This is my 95% confidence level. And now who asked the question? Santosha. Who asked me the question?
Pankaj.
Okay, Pankaj asked the question. Now, Pankaj, I am asking. Pankaj, what is going to be your exam score? What is your confidence level? Your lowest and highest?
50 to 60.
So Pankaj is saying 50 to 60. 50 and 60. His confidence level is here. My confidence level is here. My confidence level is 40 to 60 and his confidence level is 50 to 60. Is there an overlap here?
Yes.
Sir, we are unable to see your screen. Are you sharing any screen?
Is it visible to all or not visible?
Yes, sir, it is visible.
No, sir, no.
Visible, visible, sir.
It is visible, right? Maybe your net connectivity is the problem. See here, in all this region, we have our confidence limit interfering. When our confidence limits are interfering, I will not consider the situation as significantly different. Right? Suppose even, let us say, he says he will score between 60 to 70. Then also I will not consider Pankaj's performance as better than my performance. Though my range is 40 to 60, his range is 50 to 70, there is more chances that we both can score equally. Can you notice that? We both can score equally in this region. So I will not accept that Pankaj can score better than me. Chance is there, but how much is the chance? 5%, 10%. I will take decision only if I am able to gain 95% confidence. Clear? So this is visualizing the confidence limit. Always when you visualize the confidence limit, if the confidence limits are coming like this, now tell me, is there a statistically significant difference? Yes or no?
Yes.
See, my average is here. Your average is here. Is there a difference between the average? Yes, there is a difference.
Oh, yes, sir.
Yes, there is a difference.
Yes.
My confidence limit ends here. Your confidence limit ends here. There is no overlapping. Now, let us say Pankaj average is here, 75. My average is here, 65. Now I will say Pankaj, performance is better than mine. And this statement comes with 95% confidence. This statement comes with, because the 95% confidence limit do not overlap. Can you see that?
Yeah.
Whenever the confidence limits are not overlapping, right? And you can say the difference is significant. Suppose the same situation, let me say my one side confidence limit comes up to this. Now I have got, let's say, 71 here. My upper confidence limit is here. Pankaj upper confidence limit is here. Now will you still say Pankaj is better than me? And do you think your confidence level is still 95%? Now I started performing better. Can you notice that?
Yes.
So your confidence level on Pankaj will definitely drop now. Whenever you are not able to gain 95%, we will not consider the difference as significant. Whenever we gain 95% confidence, we will say that the difference observed is significant. See, there are two words. One is different, another one is statistically different. Different means two number, 60 and 65. Is there a difference? Is there a difference?
Yes.
Yes, there is a difference. This is mathematics. This is mathematics. I am asking you now, is there a statistical difference between the two numbers? Is there a significant difference? Then you should ask, sir, what is the confidence limit on this number? 95% confidence limit for first one, right? Let us say it is here. 95% upper confidence limit. Then for the next batch, what is the lower confidence limit? It is here. Is there an overlap? No. Still there is a gap, isn't it? Still there is a gap, which means you can now confirm the difference is statistically different. But if the confidence limits are overlapping, let us say the 60 comes up to this, the 65 comes up to this, and now there is a overlapping. If there is a overlapping, I will not use the word significantly different. The significant should not be used. There is a difference, but not significant difference, which means statistically there is no difference. Say for example, we conduct the exam. Now Roshan scores 80 marks. Our Pankaj score 81 mark. Does it mean Pankaj is brilliant than Roshan? Roshan is 80. Pankaj is 81. Does it mean Pankaj has learned more than Roshan?
No.
No.
1 mark can be, by random chance also, isn't it?
Yes.
So that's why we should carefully use the word significantly different. But when the Pankaj score is 40, but Roshan score is 40, but Pankaj score is 70, and now my confidence on Pankaj is more. I will say, sir, Pankaj is putting a lot of effort, sir, but not more.
Significant.
So the point to understand is whether the confidence limits overlap or not. Upper confidence limit of Roshan should not overlap with the lower confidence limit of Pankaj. If that is not happening, it is not only different, it is statistically different. If it is statistically different, you can use the word significance. The difference is significant. You can make a conclusion. All right. So I'm just taking you to Minitab quickly. See here, I want to write some numbers. 12, 13, 14, 15, 16, 17, 18. So these are all here also. One more number 15. So these are all, let's say, the performance of Roshan, right? And then we have comparison with Pankaj. So Pankaj, I have some marks, right? 18, 19, 17, 15, 14, 12, 11. Clear? Now, this is performance of Roshan and this is performance of Pankaj. And now, I'm going to start, go to basic stat, display descriptive statistics for first Roshan. I double click the Roshan. And now I click the statistics. You see here, so much statistics are there. We have learned only certain things. Whatever we learned, I have ticked it. We know mean, we know standard error of mean, we know standard deviation, we know variance, minimum, maximum. Whatever we know, I picked up, right? Let us not worry about the remaining. We will learn in due course. So, okay, and again, okay. Can you see the description of performance of Roshan here? All of you? Can you notice what is the mean score of Roshan? What is the mean score of Roshan? 15.571. And standard deviation is there for Roshan, standard error of mean is there, everything is there. And now I do it for what do you call our Pankaj. Now this is for Pankaj. I select yes. Now same statistics. When I go there, it is the same thing. Again, I give okay. And now what is the mean score of Pankaj? What is the mean score of Pankaj?
15.14.
Now tell me who is better.
Roshan.
If you are saying Roshan is better, your answer is mathematical answer.
No.
If you are a manager, if you are a leader, your answer should not be mathematical. Your answer should be statistical. Right?
Yes.
What you observed may also be wrong. What you observed may also be wrong. It is only a sample of performance of Roshan and Pankaj. The sample is telling me that Roshan is better than Pankaj, but reality may be different. We should not fall into that trap. So we have to do a statistical testing. What is that we have to do? We have to do statistical testing of
Mean.
the difference in the mean. Clear? And this is called two sample t-test. This is called two sample t-test. Let's see, this is little, we are going advanced, but this we will be teaching you in the main course once again. So let me show you quickly.
Before we proceed, I have a question.
Ah,
So we find the mean is, we don't have any difference in the mean between Roshan and Pankaj, but when we compare the standard deviation,
yes.
so Pankaj's standard deviation is higher compared to Roshan. So
That
please
is
consider
exactly. That is why there is uncertainty. When standard deviation is more, uncertainty is more, error is more. That is why I am suggesting you to not take decision under such situation. Whenever standard deviation is more, the risk is more in your decision. Uncertainty is more, risk is more means you will not be able to gain the confidence. And see here, that will become very obvious now. Let us go to stat, basic stat. Can you see two sample t-test here?
Yes.
Now, both sample in one column, no, both sample in one column. Sample 1 is Roshan, sample 2 is Pankaj. Option yes. Okay. So now I give okay. Again I give okay. And see here, now some result has generated. Some result has generated. What is very important for me? The confidence interval for difference. Oh, confidence interval for difference came, right? Stat, just a second, basic stat. Example. All right, no worries. So now we actually did a study, and now the mean is listed here. Roshan mean is available, and the Pankaj mean is available. Standard deviation, yes, correctly pointed out by one of you. There is the standard deviation is too high, and that is why that is what is actually pulling down our confidence limit. And now the difference always, when we do the statistical testing, we consider that the difference is generally the difference is no difference. Generally, we have to make a statement. There is no difference between Roshan and Pankaj. So that is what is, but that is written here. So difference of mean of Roshan and mean of Pankaj. This is the difference. And now what we do is we calculated something. What is this? Can one of you read out?
P-value.
Yeah. Please note. P-value me is probability of significance, which is nothing but estimate of type 1 error, which is nothing but estimate of type 1 error. This type 1 error should be always less than 5%. Should be always less than 5%. If it is less than 5%, then you can understand your confidence level is above 95%. But in our case, how much is the p-value?
75%.
P-value is 75%, which means type 1 error is how much? 75%. Under this situation, if you take a decision, you may land up committing an error of 75%. There is only 25% chance is there for you for your decision to become true. What is your decision? You said, sir, Roshan is better. Roshan can be better. And how much is the chance for that to happen? 25%. So whenever you are not able to gain the 95% confidence, you have to understand that the difference is statistically insignificant. Better say like this: the difference is statistically insignificant. There is difference. When you say there is difference, what is this? This is mathematics. When you say the difference is statistical, when you say the here, when you say difference, this is mathematics. When you say the difference is statistically insignificant, this is called statistics. All of you understand the difference between max and stats?
Yes.
When we will say the difference is statistically significant, Difference is, when we will say difference is statistically significant,
If p-value is
p-value is less than 5%.
less
P-value
than 0%.
less than 5% means there is no overlapping of confidence limit. The tool is just telling us. You don't have to visualize everything. You don't have to create graphs. Straight away, looking at the p-value, you can understand. But you will be learning what is exactly p-value and how to calculate the p-value in the analyze phase. But then that is the reason why I did not start with the p-value. I just started with the confidence limits. And here also, for what you say, for Roshan, we can calculate the confidence limit. For Pankaj also, we can calculate the confidence limit. And you can easily see the confidence limit crossing each other. You can easily see confidence limit. I mean, the upper confidence limit of Roshan might go beyond the lower confidence limit of Pankaj. And when that overlapping happens, you should not take any decision under such situation. All right. So I would like to stop here. If there are any questions, please ask. Otherwise, I think this is a good dose of stats. Any question anybody would like to ask?
No, no question from my side. Thank you.
But is that you are able to grab the points which we discussed today, or do you think it is difficult for you to observe?
No, at least for today, it is good, means can understand.
All right. Okay, so definitely if you start using, I think all of you have you installed the Minitab link was not given, right?
No, not given.
All right. So I will post the Minitab link in the WhatsApp group, and whoever has the permission to install the Minitab in your software, if you have a personal laptop, please install it, and then you can also start playing. So you can visualize many things easily, and then that will help you to learn. So I'll share the Minitab link, and because next week onwards, whatever we are doing, you can also parallelly practice.
Okay.
All right. So thank you all for joining.